Alright, lesson 11 homework. We're gonna get through this and then we'll take our quiz. So we'll actually do the warm-up tomorrow. So I want to give you as much time on the quiz as possible. So first example here, which ones are perfect squares? That means they are the exact same thing. Well, A is, they're both x plus 5, right? I can write it as x plus 5 squared. This one, they are both a positive c and a negative 9, so that one doesn't look like it, but it actually is. They are the same. D is the same, a positive 3 and a positive a. And G is the same, positive a and a positive b. Question number 2, filling out the charts. Two of them are done for you. You got to do the last one. You should have h squared, 1/3 h, 1/3 h, and 1/3 times 1/3 is 1/3 squared, or 1/9. How are the constants of the three alike? Well, cell 1 is always first term squared. All right, n squared, 5 squared, h squared. Cell 2 and 3 are both the same. On these perfect squares, they are both terms multiplied together. N times 7, 5 times negative m, h times 1/3. So first term times second term. And cell 4 is always the last term squared. 7 squared, negative m squared, 1/3 squared. Okay, just looking for the patterns of those. Okay, rewrite each one in standard form. So the first one should be n squared plus 14n plus 49. That's just using the chart that's on the previous page, or foiling. Second one is 25 minus 10m plus m squared. Again, I would rewrite that so it's in the same form as the original. And the third one should be h squared plus 2/3 h plus a 9th. Says, how are a, x, b, bx, and c in standard form related to the two terms? Okay, we already talked about that. That's like talking about the cells. This is the first term squared. This is term 1 times term 2. Doubled. All right, 7n and 7n, 5n and 5n, 1/3 h and 1/3 h. And the last one is last term squared. So pretty much how the equations relate to the charts that you just did. Next one, solving. So it's up to you which method you wanted to do. These are perfect squares. So you could simply take the square root of both sides. Add 1. And I get 3. And negative 1. Okay, you can do that for all of them. You should get negative 14 and 4, 2, negative 22 and 0, and 41 over 7, and 57 over 7.
What is the last one?
Question number 4, explain or show why there is no middle term. Well, I would take 2x times negative 1 and 2x times positive 1, and they would cancel out. If you have the same thing with just different signs, you will never have a middle term. Question number 5, complete Hans' work and solve. Okay, so if we're going to continue on with Hans, we would have to subtract 4 to get it equal to 0. Factors of 5 that add up to 6 are 5 and 1. So my answers are -1 and -5. Okay, Jada's reasoning once again is to take the square root of both sides. So I get x plus 3 equals 2, and x plus 3 equals -2. Subtract 3, and I get -1. Subtract 3, and I get -5. Can Jada use her reasoning to solve this one? No. You cannot take the square root of either. It's not a perfect square. Now, do you remember what absolute guessing error is?
Yeah.
Okay, it is how far off of this number are you? So if I guess 190, how far off is that from the original?
45.
So it should be 45, 5, 20, 12, 22, 15, 3, 55, 25, and 30.